Ever wondered how data is sent between devices on a network without establishing a reliable connection beforehand? The answer lies in a protocol known as the User Datagram Protocol, or UDP for short. UDP is a minimal connectionless transport layer protocol within the Internet Protocol suite. Its key features are quite unique. First, it's connectionless, meaning it sends packets or datagrams directly without a handshake process, making it faster for transmitting small amounts of data. Second, it offers unreliable delivery. Packets may arrive out of order, duplicated, or not arrive at all. It's also non-sequenced, with packets arriving in any order, and it's up to the application to reorder them if needed. Lastly, it's stateless. There's no state maintained between sending and receiving endpoints. Each UDP packet is treated independently of others. In short, UDP is a protocol that prioritizes speed over reliability, making it well-suited for certain types of applications. Now, let's delve into the workings of UDP. It all starts with a datagram. A UDP datagram is a compact package of information consisting of a header and a data section. The header is like the envelope that carries the data, and it contains 4 very important fields: source port, destination port, length, and checksum. The source and destination port fields are like the addresses on your envelope. They are used for directing the datagram to the right applications on the host devices. The length field is pretty self-explanatory. It specifies the length of the entire datagram, including the header and the data. Lastly, the checksum field is used for error checking both the header and the data. However, it's interesting to note that its use is optional in IPv4, but mandatory in IPv6. Now let's walk through the sending process. Imagine an application that wants to send data using UDP. This application hands over the data, along with the destination IP address and port number, to the UDP protocol. UDP then wraps this data into a datagram, attaching its header, and passes the datagram down to the IP layer. Here, the datagram is further packaged into an IP packet and sent off towards its destination. On the receiving end, the process is somewhat reversed. The IP layer processes the incoming IP packet, peels off the IP header, and passes the UDP datagram up to the UDP layer. UDP then checks the destination port number in the header and forwards the payload to the corresponding application based on this port. If the checksum field is used, UDP also checks the integrity of the data. If there's a checksum error, the datagram is silently discarded. Otherwise, the data is passed to the upper application layer, and that's it. There's no handshake to establish a connection, no guarantee that the data will arrive, and no particular order in which the datagrams must arrive. That's the simplicity of UDP. No handshakes, no guaranteed delivery, just fast, direct communication. You may be wondering, where is UDP actually used? Well, the answer might surprise you. UDP, with its low latency and low overhead properties, is the go-to protocol for time-sensitive applications where a bit of data loss is tolerable. Think of real-time applications. For instance, voice-over IP services, online gaming, and live streaming thrive on UDP's speed, accepting occasional data loss as part of the game. Broadcasting and multicasting applications are another area where UDP shines. The connectionless nature of UDP makes it a perfect fit for these types of applications that need to transmit data to multiple recipients simultaneously. And let's not forget simple query response protocols like the domain name system and the simple network management protocol. These protocols need quick, single-shot data transfers, and UDP is just the right protocol for the job. In these applications, a little data loss is a trade-off for the speed and efficiency that UDP offers. Let's dive into the nitty-gritty of working with User Datagram Protocol, or UDP for short. One of the key considerations is the trade-off between speed and reliability. UDP is fast thanks to its connectionless nature and lack of handshake process. However, it doesn't guarantee the delivery of packets, so if you're transmitting data where every bit counts, you might need to rethink your approach. Implementing flow control, error correction, and ordering at the application level is another aspect to ponder upon. UDP treats each packet independently, which means they may arrive out of order, duplicated, or not at all. So if your application requires these features, you'll need to handle them yourself. This could involve implementing custom protocols on top of UDP, or using application-level libraries that provide these features. It's all about understanding what UDP brings to the table and how you can supplement its limitations to suit your needs. Despite its simplicity, using UDP effectively requires a clear understanding of its strengths and limitations.